So, hello, welcome back. We'll be working with group anagrams now. So, the problem basically, how to say this? It's a pretty confusing problem. I won't lie. It has a list of different strings. So we have TAR, RAT, TA, sorry, ATE, TEA, and let's say EET. Okay. So we have these strings, and what we have to do is we have to find the anagrams out of these strings and then group them together. For example, RAT and TAR, this is a anagram pair. No one else has an R, right? So RAT, comma TAR, then ATE, and EAT as a pair. We'll return this pair, and it can have more groups as well. I can have 3, 4, etc. Like I can have a lot of groups. The order also doesn't matter, but we have to return this pair. How do we work with this? One way is to take every element and then sort it. So ART, ART, AET, AET, AET. So with this, these all the common ones or all the same ones would be paired, and or you can get the index of every item which is similar, and then pair those items at that index. So this is at 0, this is a 1. Get the index 0, 1, and then pair these two. This is one solution, but this is very highly complex because we have n log n. There's the sorting. There is time complexity for sorting. Okay, this n log 0, we go of n log n. On top of that, we have big O of m into n. And what is big O of m into n? Would be the size of each string into n is the number of strings. So m is like, let's say, maximum size of 3 string. So this is very, very bad. Now the other way would be, instead of sorting it and taking every string, why not create a count, or create some kind of a parameter which is unique for a group of anagrams. For example, we take the rat and tar example. Now, if I were to count, or if I were to create an array where I would count all the alphabets, then this is the array 0, 0, 0 up to 26 zeros. Okay, let's say 0, 26 zeros. Okay, 26 zeros. Or if I were to use this array and create a key out of it, that would be great, right? Because this counter array will always be unique. For example, if I were to count everything on TAR, I'll always get only one T, only one A, only one R. And every anagram of tar needs to have these 3. So it's always unique. So make sure that when you're trying with hash maps, right? Try to always use a unique key, a key which will be always unique, and it can have multiple values. So it needs a group of anagrams. It needs a group of anagrams, right? Then I can have a unique counter array here, which will count all the alphabets, and then append every string that I find that has this particular count of characters. So this automatically makes all of these strings an anagram of each other. So this way, we'll use the counter array for every alphabet in that anagram, and then that alphabet array would be treated as a unique array. Let's go code this.
Okay, so let's start coding. So you can see on the question on the left hand side here, and we have some examples. As you can see, all the anagrams which are similar are grouped together. ATT, Natan, BAT. Since BAT was the only one. And if you're sending an empty string, it should return an empty string. If we have a single character, it should return a group with a single character. That's it. Pretty self-explanatory. Now let's go. So first, we need to send a list, right? A list which contains multiple groups or multiple sets. So we'll create a dictionary. Okay. Now, how were we planning to return the values? We were planning to return only the values, key value pair, right? Key would be the alphabet array, and the value would be the set of strings which are an anagram, right? Like similar anagrams, basically group anagrams. So we'll create a dictionary which will collect, so which will contain list as its value, because we have one array as the key value is a list. So default dict basically creates a dictionary, empty dictionary by default, and it will use the data type that you're sending in the brackets. For every anagram, so for anagram in strs, so this is the list of anagrams, right? So for one anagram in the list, what we'll do is we'll have to create an array of 26 indexes with for every alphabet, for every single string, every single anagram string. So if I were to just mention the anagram string, okay. So the result. Now for every anagram string in the strs, let's create a sorry, okay. This will basically have a counter of all the alphabets, and I want 26 such indexes, sorry. So for every char in the anagram string, what are we going to do? The count char will basically take the index of the current value. So let me rename this to character actually, because char is fine. I think I misspelled character. Anyways, so count char, ordinal of char. What this does is it gets the ASCII value. Let's take I'm not sure if it's the ASCII value or UTF-8 value. Basically, it will convert the character into a integer value of its definition. I'm not sure if it's a ASCII or a UTF-8. So I want to subtract this value with ordinal of character A. So what will this do? If the character is A, I'll get 0 here. So A minus 0, 0. And then the counter at index 0 will be increased to 1. So this is how we are counting all the characters. Now, how do we add it to the result? Result will be tuple of count char. So this will basically be the key. Okay. Dot append with the current string, which is this one. There we go. So what it does is, this is the key, which is the character frequency, alphabet frequency. So what it does is, it takes the alphabet frequency as the key and appends the current string that we went through. And if I find another, let's say another similar, basically another anagram of the same, with the same alphabets, it will have the same alphabet count. So when I go to this line result, it will look for that particular exact same key value, which is the same alphabet count, and then append this particular anagram string to that list, to that key. And lastly, we'll just return result dot values. There we go. If I run this, I'm hoping I don't get any issues here. Okay, there's a runtime error. Collection is not defined. Oh, sorry, collections. My bad. Should be collections. There we go. So we have all these cases passing, and I'll submit it now. It's accepted. Great. Sure. See ya in the next one.